Hello and good day, geometry. We are covering PO20, parts 1 and 2 today, and it's directly related to CO19, or that's a PO, I think it's PO19, isn't it? Yeah, directly related to PO19 is that all of those relationships that we talked about, corresponding angles, alternate interior, alternate exterior, consecutive interior, they actually come from postulates and theorems that we're going to be able to use when we do some more proofs down the line here. So PO20 part 1 is, it's a lot of writing. So get those wrist exercises going with your writing hand up in the air, forwards, backwards, round, and let's get to work. Okay. So the corresponding angles postulate, you'll recognize these as if-then statements. But if two parallel lines are cut by a transversal, if two parallel lines are cut by a what happened there? Oh my goodness. Cut by a transversal, then the pairs of corresponding angles are congruent. Corresponding angles are congruent. Okay, and in fact, all of these are going to start with that same if statement. If two parallel lines are cut by a transversal. So if you want to write it out for all of them, then you may. If you don't want to, then that's fine as well. I clearly need the penmanship practice, so I will be writing them out for all of them. But it is the same because that's kind of what we're talking about. All of these relationships with congruency and the consecutive angles being supplementary, they all have to do with parallel lines here. So the next one, the alternate interior angles theorem. If two parallel lines are cut by a transversal, cut by a transversal, then the pairs of alternate interior angles are congruent. Okay. Wow, speaking of the word congruent, look how congruent my writing is for those two. I guess only specifically between the U, E, and the N, really just the N. And yeah, really just the N. But anyway, they look very congruent. The alternate exterior angles theorem. If two pairs, oh, no, not two pairs. If two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. Isn't it kind of funny how the word parallel has a double L in there, like parallel, because the L's are parallel? I always found that kind of funny. That's what helped me remember how to spell it, because it's got the double. Anyway, okay. And then consecutive interior angles theorem. If two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are something different, some variety, supplementary, right? That's the one that is, it breaks the consistency of the other three relationships. They are supplementary, not congruent. Supplementary. Okay. Give you a little bit of time to finish writing those. Okay. And then, and again, the reason why we're doing these, they're all key points. It's just all more tools for your toolbox when doing proofs in the future. If you've got this transversal with parallel lines, you can say that angles are congruent based on their position, based on their relationship. Okay. Let's go up to the top. Oh, too far. Too far. Why is no one surprised that that happened? Okay, the corresponding angles converse. And by the way, these are in your book, sections 3.2 and 3.3. If you want pictures or just to jot them down, that's where they are. Corresponding angles converse. This is the converse of it, and we know what that looks like. It means that if we know corresponding angles are congruent, it means the lines are parallel. So if we've got the parallel lines, then we can conclude corresponding angles are congruent. The converse says that if we know that the corresponding angles are congruent, then we can conclude the parallel lines. So what this says, if two lines cut by a transversal so that corresponding angles are congruent, then the lines are parallel. Okay, so again, it's exactly the opposite position, the converse of the theorem or the postulate that we wrote up above. This time we have the corresponding angles congruent, therefore we can conclude the lines are parallel. The alternate interior angles converse says that if two lines, this is going to sound familiar here, if two lines are cut by a transversal so that the alternate interior angles are congruent, then the lines are parallel. Oof, my wrist is actually starting to hurt here. You have the luxury of pausing and coming back to it later, or maybe not writing them down at all. Not recommended, but here we go. Since I don't know how to edit, it's just a straight shot here. Alternate exterior angles converse. If two lines are cut by a transversal so that the alternate exterior angles are congruent, then the lines are parallel. The consecutive interior angles converse. Ready? 1, 2, 3. Big ol' if two lines are cut by a transversal so that the consecutive interior angles are, this one's the different one, supplementary then the lines are parallel. Okay, so we have the converse for each of the four theorems or postulates that we had up above. Basically, if you know the lines are parallel, you can conclude these angle relationships. If you know the angle relationships and they're congruent or supplementary, then you can conclude the lines are parallel. Okay. The transitive property of parallel lines. Remember, the transitive property in and of itself is if A equals B and B equals C, then A equals C, right? If two different things are equal to the same thing, then they're equal to each other. Kind of have the same thing here. The transitive property of parallel lines says that if two lines are parallel to the same line, if two lines are parallel to the same line, then they are parallel to each other. If two lines are parallel to the same line, then they are parallel to each other. Okay? Whew. So there you go. Pens down. Okay? Your homework on PO20 is not going to be a quiz, just the way that this is set up. If you turn the page here, you see we've got 3 diagrams that I'd like you to fill out, and putting this in quiz form is be far too difficult. So I will be checking this in. Class will be back in session on Monday the 30th. We are only going to have one class next week because we have Friday off. So we'll have the blue group meeting on Monday and the gold group meeting on Wednesday. So one class for each group next week, Monday and Wednesday. Your test scores, you got your test back on Tuesday, but scores haven't posted in Educate for a while. Take a look on there. Any objective that's less than 100%, so even a 3 out of 4, you can retake. Same process as algebra. Email me the practice work or drop it off at school, and I'll get you the retake, and you can take it. So anyway, so the first one here says, find the measures of each angle marked with a red dot. So you are using your toolbox here. I will tell you that these 3 lines, A, B, and C, are all parallel. And when you've got, 3 lines that are being intersected by 1, 2, 3, 4 different transversals, just keep in mind here, like this angle here corresponds with this angle here, corresponds with this angle here, right? They're all in the same position as you follow that transversal through the 3 lines that it intersects. So all 3 of those would have the same measure. Same kind of thing here. Let's see, let me see if I can give away. This, well, no, I don't want to do that. Sorry, I'm trying to get a relationship on the fly here. It's not really working out too well. Looking for an example to show you. But just kind of to get you started here, I mean, if you look at this 114, I'll start there. You do have a vertical angle going straight across, so that gets you this to be 114 as well. I guess this will work out to be a pretty good example. That 114 is a corresponding angle. It's an obtuse angle here. That corresponds with this whole angle right here and this whole angle down here, right? So if you know that top angle there is 114, that can get you this dot. It's not obviously 114, but since that angle includes both the red dot and the 71, 114 minus 71 would get you the measure of that red dot. You could also get that by looking at vertical angles from this 43 here. It's going to be congruent. So that red dot being 43, if you add 43 and 71, you do get 114. So there's geometry being like that puzzle that we've talked about. You know, all of this stuff is going to fit together. Every relationship that you look for is going to work out, okay? Because it all fits here. So let me just throw out another one. I guess this, no, maybe I'm not. Sorry for being so indecisive here, but I'm trying to help you out with not giving away too much information. So the other thing I'm going to point out, though, is that be careful of relationships that exist here. You know, you may think that those are consecutive interior angles, okay? But they actually aren't, because the lines that are being intersected are these horizontal lines here. So the angle that is going to be consecutive interior with this red dot, you don't look at this other transversal D intersecting E, you're looking at this angle right up here, right? That one that connects the transversal to the that top horizontal line is where consecutive interior angles are going to lie. So when you're looking at angle relationships, try and block everything else out. You know, if you're just looking at this vertex and this vertex here, where the transversal intersects that horizontal line, right? Block everything else out. Okay, that's going to help you here. The bottom two, more diving into our toolbox, okay? Lots of triangular stuff here. You look at this one on the left here, you're only given 3 angle measures, and there's a lot that you have to find, you know, but figuring out angle A should be relatively simple if you remember the corollary to the triangle sum theorem. We have a right triangle there and a given angle. That should help. Angle D here, well, there's a relationship that exists there between the 75 and the angle D. Nothing with parallel lines, but think back to all those things that you have, LPP, okay? That'll help there. It may help you, you know, any triangle is going to add up to 180. So we've got a triangle here with the 38, angle E and angle D. But we also have a triangle here, right? That also includes angle 38, but now has E and B together, and then angle C down here too. That triangle, both the one I highlighted in green and the one I just highlighted in red, will add up to 180. They both have to. All triangles do. So use all those relationships. Same thing here. The one on the right, a whole bunch of triangles to work with. I mean, you've got all these small triangles that you can see with the right angles. Okay, got all those. I see a triangle here involving angle Q, angle N, and a missing angle there. We have a triangle that comes down here, right? So they're all over the place. Okay, you have to look for them. And remember all those things: vertical angles, linear pairs. You know, everything that we've talked about here is going to be at your disposal. All right. So solve for every red dot angle in the diagram up above. Solve for all the variable angles in the two at the bottom. The first one, you got A, B, C, D, E, and F, and then you've got M, N, U, T, S, R, P, and Q in the diagram on the right. Okay? All right, folks. Whoop, just turn off my mic there. That's all I've got for you for this objective, PO20. Just looking at those angle relationships, pulling everything back that we've done so far. The bigger your toolbox, the fuller your toolbox, the more you've been keeping up with the relationships we've already talked about all the way back to Unit 1. The easier this is going to be for you. So bring this to class on Monday or Wednesday when we meet next week. Have a great Thanksgiving. I'll see you on Monday. Do not forget to like and subscribe.